This unit is all about functions, and what we have here are two functions. One is called f of x right here, and the other one is called g of x. Now we can manipulate these functions, and what I mean by that is sometimes we can add the functions, sometimes subtract, sometimes divide, and sometimes multiply. Think about that as a dot. And so this is the notation that means add the functions, subtract the functions, divide the functions, and multiply the functions. So that's all that those four notations mean. Let's go ahead and actually do it. So if I wanted to find f plus g of x, I'm just going to add those two functions. So I'm going to have an x squared minus 4 plus an x plus 2. Well, the only thing that I can combine in this case is going to be the minus 4 and the plus 2. And so this whole thing is going to be equal to x squared plus x, and then a negative 4 and a plus 2 is a minus 2. So what I have boxed here is equal to f plus g of x. All right, let's go ahead and let's try another one. I'm going to erase that, so make sure you have that down. All right, with f minus g of x, you have to be really careful that you put your parentheses. And what I mean by that is that this is going to be equal to my f function because it's listed first. And then I have to do minus the entire g function, which is x plus 2. So distributing that negative, we're going to have x squared minus 4 minus x minus 2, which is going to be equal to an x squared minus x, and then combining my minus 4 minus 2, I get a negative 6. So this x squared minus x minus 6 is equal to the f minus g of x. And so you should be getting a hang of this. You should realize that, oh, the next one represents dividing the two functions. So let's go ahead and do that. This is going to be equal to, remember my f is on top according to this notation. So it's going to be an x squared minus 4 all divided by an x plus 2. And you might recognize that that actually can be factored, but for now let's go ahead and leave it just like that. All right, the next one is stating that we can multiply these two functions, and that's simply going to be an x squared minus 4 times an x plus 2. And again, we could multiply that, but for the sake of understanding the notation, that is sufficient. All right, let's move forward. So just to kind of summarize everything that we've talked about, if you see this notation, it's the same thing as saying add f of x and g of x. If you see this notation, it's the same thing as saying subtract the two functions. If you see this, it's the same thing as saying multiply the two functions. And if you see this, it's the same thing as saying divide the two functions. So that's our notation that we need to know about. All right. Here's some more practice. We've got f plus g of x, and it's a little bit more work, but we're basically being told to add these two functions. And so that's going to be equal to a 4x squared plus 2x minus 5 plus, and if you want to put parentheses, you can, but distributing a plus will give you the same exact function, and so it's not necessary here. And so right now I'm just copying down that g of x. And so we're just going to be smart about adding our like terms. 4x squared minus the 3x squared is just a positive 1x squared. A 2x and a minus 6x will give me a negative 4x. And lastly, a minus 5 and a plus 2 is going to give you a minus 3. And that will be your answer for f plus g of x. That's how you say that, f plus g of x. It's kind of an invisible word of right here. All right, for the next one, however, if I'm subtracting, I do have to be really smart about remembering to put my parentheses, minus parentheses my g of x. Okay, and then my next step would be to distribute that negative. So that's going to give me, rewrite all of this. It's going to be a positive 3x squared, a positive 6x, now a negative 2. Combining our like terms, that gives us a 7x squared. A 2x and a 6x gives me an 8x. And a minus 5 and a minus 2 gives me a negative 7. Now, folks, we have been doing this mainly with f first and then g, but just keep in mind that it's no problem if we switch those two letters. It's just that you would have to change the order that you're adding or subtracting. All right, now we're going to talk about something that's a bit harder, and this looks more similar to what you'll see on your exam. This one's asking you to do f divided by g of x, but it's also asking you to state the domain. So all we have to do for f divided by g of x is divide and be smart about the fact that the f of x goes on top, or in the numerator. Now we're dividing by my g of x, which is actually a fraction. Now we should know from Algebra 1 that dividing by a fraction is the same thing as multiplying by its reciprocal. I write that down for those who don't remember that. Dividing by a fraction is the same as multiplying by its reciprocal. Okay, so maybe pause the video, get that down. An example of that might be that 5 divided by 1/2 is the same thing as 5 times 2 over 1. Okay, we'll rewrite 5 as a fraction. We get 5 times 2 is 10 over 1 equals 10. So see how I'm dividing by 1/2, so I'm multiplying by 2 over 1 here. Okay, so getting back to this, see how I'm dividing by a fraction? And I just told you that's the same thing as multiplying by its reciprocal. So I'm going to rewrite the square root of x plus 7, but now instead of dividing by this fraction, I'm going to multiply by 2x plus 5 over 1. Well, when I do that, when I multiply fractions, you should know that we multiply across the numerator and we multiply across the denominator. So my numerator is going to be these two things multiplied. And my denominator is going to be 1 times 1, which is just 1. And dividing by 1 is the same exact thing as just writing it like that. So this is your answer. Now we are not done. It asks you to state the domain, and we know that there are two possible issues with the domain. One is if we have an x in the denominator, that could be 0, and the other one is if we have a square root. Well, the issue that we have today is the square root, and we know that we cannot have a negative. We know that our x plus 7 has to be greater than or equal to 0. Subtract 7, and I get x is greater than or equal to negative 7. So that's my domain. And if you want to, you could write it like from negative 7 to infinity. That would be my domain, or I could also say this right here. All right, let's do one more problem that's exactly the same type of problem, but we should be faster with it now. All right, this problem wants you to find f times g of x and state the domain. So notice how this is now multiplying. So this is going to be square root of x, 2x plus 4. And now we're going to multiply it by 1 over 2x plus 5. When we're multiplying things, we can put this over 1. So our answer is going to be the square root of 2x plus 4 over 2x plus 5. So that's our answer, but we also have to take a second to state the domain. And remember, the only problems we can have are if we have a square root and we have something that could be 0 in the denominator. Well, we have both of those situations. So the first thing we have to deal with is setting the 2x plus 4, which is the thing under the square root, greater than or equal to 0, because we can have the square root of 0, but it has to be positive. So this disappears. I get 2x is greater than or equal to -4, divided by 2. I get x is greater than or equal to -2. But I also know that my denominator cannot be 0. So I set 2x plus 5 equal to 0, subtract 5. Okay, and I get 2x equal to -5, and then I get x cannot be -5 divided by 2. Well, if we look at a number line, we know that x has to be greater than or equal to -2, but -5 divided by 2, we can't have that either. But notice how that's actually a -2.5 that we can't have, which is no big deal because we've already stated that you have to be bigger than -2. That's already eliminated the fact that you can't have that. All right, so our domain is going to be from -2 to infinity, or you could have just simply said what I'm boxing right here. It certainly wouldn't be wrong if you stated this and said it cannot be equal to that. It's just redundant, if you will. So I prefer this or this, and that's it, folks. Thanks for watching.